The second or other side of your note page has a flow chart diagram of the scientific method, and this video zoomed in on the first part of it. But as you can see, if you look at the entire note sheet, the scientific method again is a circular or cyclical type of process. It really doesn't necessarily have to have a complete end to it. So we start off with, of course, observing. What is it that you see using your senses, your eyes, your ears, of course, sight, sound, smell, touch, taste, all those types of senses can help you make valid observations as your starting point. So step one, using your senses to observe, is going to lead to step two, where you can ask a well-defined question. So using what you've seen, a well-defined question is not going to be general or vague. It's going to be a little bit more specific based on what you have seen. After coming up with a very well-defined question, you're going to want to write, again, a testable hypothesis. And the hypothesis is usually stated if and then. So, for example, if I give the rose bushes a half a liter of water every other day, then they will grow 5 centimeters weekly. That's just a brief example, but using if and then with numbers in there that you can actually test and measure. Once you have come up with a testable hypothesis, you need to make a plan. And this plan includes the details of the test. So you would want to put a step-by-step, very detailed plan. A lot of times scientific explorations or experiments fail because the plan was not thought through, steps were not taken. All right, the step that everyone really likes the most is time to test, doing the experiment. You can do it in a lab, but a lot of scientific experiments using the scientific method are not done in a lab. Not every experiment is going to result in something burning or blowing up, making a sound. Most experiments are not focused on that. But this is where you would follow your detailed plan to carry out your experiment. As you are carrying out your experiment, you're going to collect your data. Remember, data are pieces of information. And you are going to then look at your pieces of information and evaluate them, interpret, and analyze. And again, the best way to do those things is to put your information on a chart, table, or graph. To evaluate, you want to see, do these numbers make sense? Interpret, what do the numbers mean? And then analyzing is putting all of that together. Our next step is, again, that word, critique, where you're coming up with your conclusion. And there's another key word, it should be logical, it should make sense. I know on the note page it says the end, which I would kind of cross that off because it's not really the end. Yes, your conclusion may be logical and your numbers make sense, and maybe you have proved your hypothesis, and that is great. You're still going to want to look at it and think about what could we do differently, what could we expand upon and think about more and test more. This is also the point where you look at it and think, well, the numbers are not logical. I don't have a good explanation. Now I need to figure out, what did I do wrong? How can I do it differently? And here is the arrow leads to this bubble in the middle. If no logical explanation, go back and rewrite, revisit your hypothesis. And I would say you may have to go back even one or two steps further. Maybe your observations were flawed. Maybe your question wasn't very specific. And then that made your hypothesis not very accurate. So as you can see again, the scientific method is a process that goes in a circle, cyclical, that is something that is used worldwide and that we will be using in class here, and we want you to have in mind throughout the school year. As a reminder, bring this copy of this notes, bring your notes with you. This will be part of your grade tomorrow on the warm-up.